Dot skill presents factors. The factors of a number are all the numbers that can divide into the given number without leaving any remainder. For example, the factors of 6 are 1, 2, 3 and 6 because each one of these numbers can divide 6 without leaving a remainder. On the other hand, 4 is not a factor of 6 because if you divide 6 with 4, so if you do this division, 6 divided by 4, you have a remainder of 2. The factors of 9 are 1, 3 and 9 because these are the only 3 numbers that can divide 9 without leaving a remainder. And the factors of, let's say, 12 are 1, 2, 3, 4, 6 and 12 because these are the only numbers that can divide 12 without leaving a remainder. 5 isn't a factor of 12 because 5 times nothing is 12. Or let me be more correct by saying there is no integer that multiplies with 5 to give you 12. Recall that a prime number is a number that has got only 2 factors. And that are 1 and the number itself. For example, 11. The factors of 11 are 1 and 11 only. For example, 17. The factors of 17 are 1 and 17 only. For example, 23. The factors of 23 are 1 and 23 only. 1 is a factor of every number, and the number itself is always a factor of itself because a number can always divide into itself without leaving a remainder. Let me also remind you that even numbers are generally not prime because they always have 2 as one of their factors. In fact, 2 is the only even prime number. 2 is the only even number that's prime. And the reason for that lies in the definition of prime numbers. I said a number that has got only 2 factors, 1 and itself. Now if you think about the factors of 2, 2 has got only 2 factors, 1 and 2. So it's pretty much 1 and itself, and therefore 2 qualifies as a prime number. And the number that's not prime, like 6, 9 and 12, are called composite numbers. Composite numbers are not prime. And by definition, they have at least 3 factors. Now how about the number 1? What are the factors of 1? Well, 1 has got only one factor, 1. So it neither qualifies as a prime number nor as a composite number. 1 is the only integer that's neither prime nor composite. Factors of a number that are prime are called the prime factors of that number. So the prime factors of 6 would be 2 and 3. These are the prime factors of 6. The prime factors of 9 would be 3 only, because 1 is neither prime nor composite, and 9 of course is not a prime number. And then the factors of 12 that are prime are 2, 3, and that's all. So these 2 again are the prime factors of 12. The greatest common factor also called the GCF, sometimes called the GCD, D for divisor, of two or more numbers is the largest number that is a factor of both the numbers. Let me give you an example. The GCF of 6 and 9 is 3 because 3 is the largest number that is a factor of both 6 and 9. Similarly, the GCF of 10 and 15 is 5 because 5 is the largest number that's a factor of both 10 and 15. And the GCF, let's say, of 20 and 50 is 10 because 10 is the largest factor that's common to 20 and 50 both. We could also have GCF of more than two numbers. For example, the GCF, the greatest common factor of, let's say, 12, 20 and 32 would be 4 because 4 is the largest number that's a factor of all these three numbers. So if we were to write down the factors of 12, we have 1, 2, 3, 4, 6 and 12. Similarly, the factors of 20 would be 1, 2, 4, 5, 10 and 20. And the factors of 32 are 1, 2, 4, 8, 16 and 32. Now if you look at the common factors between these three sets, we have a 1 on all three, we have a 2 and we have a 4. So 4 is the largest of them all, largest of the common factors. Reason why we call it the greatest common factor. Time for us to try a word problem. Evans has 42 crayons and 77 pieces of paper to give to her students. She seems to be a teacher. Okay. What's the largest number of students she can have in her class so that each student gets equal number of crayons and equal number of paper? And let me also add that so that there's no crayon or paper left over in the end, which means you have to have a certain number of students who can share the 42 crayons evenly without any leftover, and also the 77 pieces of paper evenly without any leftover. So that tells us that the number of students, whatever that is, has to be a factor of both 42 and 77. Because if you divide 42 with a certain number, you don't get a leftover only when that number is a factor of 42. For example, 6 or 7 or even 2. And then similarly, the number of students has also got to be a factor of 77 so that there is no piece of paper left over in the end. And the question is, what is the largest such number? So in other words, what is the largest number that is both a factor of 42 and a factor of 77? Essentially, the problem asks us to find the GCF of these two numbers, the greatest common factor. And the factors of 42 are 1 and 42, 2 and 21, 3 and 14, 3 times 14 is 42, not 4, not 5, 6 and 7. So these are the factors of 42. And the factors of 77 are 1 and 77, and 7 and 11, that's all. These are the factors of 77, and they have two common factors, 1 and 7. And the greatest common factor or the largest common factor is 7. So the largest number of students she could have in her class is 7. So each student in that case would receive 6 crayons each and 11 pieces of paper each.